Okay, given that f of x equals ln x, sketch the graphs of y equals f of x and y equals minus f of x plus 1 on the same diagram. Label the coordinates of the points of intersection with the x-axis and indicate the behaviour of the large graphs for large positive and negative values of y. Okay, now notice here that it does say they want them on the same diagram. Okay, now there's nothing wrong with drawing multiple diagrams, alright? I would advise that, but once you finish, you need to get it all on the same diagram. So let me just show you. ln x, okay, you need to know what this graph looks like. With ln x, there are no negative values, okay, in the x area, that is. Okay, it won't take negative x values. ln x looks like this. Okay, so as x gets close to 0, ln x goes towards minus infinity. Okay, if you type in ln 0 on your calculator, ln 0 it'll say math error because it's going to infinity. But really small values of x, it starts to decrease, and it crosses the x-axis at 1. Okay, now we need to draw this as well on here. All right, now in order to do that, I'm going to label this f of x. In order to do that, what we're going to need to do is start to build this up. Okay, minus f of x plus 1. The first thing we'll do is do f of x plus 1. Remember, focus inside the bracket. So we'll do f of x plus 1. Alright, so we need to use this, f of x, to do this. Now remember, inside the bracket you do the opposite. So if it's plus 1, you're going to go back 1. You're going to do the opposite, so you're going to take away 1. Affects the x-axis, so it's a shift to the left on the x-axis. So if I shift this to the left, okay, similar sort of axes, okay, but of course what I'm going to need to do is have more negative, have some negative values for x, because if you think about it, this shifts to the left by 1. Where it's crossing here at 1, it will now cross at the origin, O, okay, and it will sort of, as I said, head off like that. So it crosses the origin O, but then if you think about it, because it crosses at 1 here, and then it goes to infinity, okay, as x approaches 0, that gap there is 1, so we need to go back 1 here, so that will take us to minus 1, and as now x heads towards minus 1, this graph will go to minus infinity. Okay, so if it's going to minus infinity at minus 1, you're going to need to draw an asymptote. It's really important that you do that. Okay, draw a broken line. Okay, and you can show then that this will go towards minus infinity. Okay, you're indicating the behavior then as what's happening. This broken line shows that it's heading to infinity. Okay. So there's your f of x plus 1. Now what we need to do now is the minus of that, yeah? Because that's what they wanted the question. If we go back, we've got minus f of x plus 1. So we need to do minus of that. Okay? Right? And in fact, I could actually, because they want it on this actual graph, I can actually go straight to do it on here. Alright? You just got to realize if you do this, this is a reflection. When there's a minus in front of f, it's just a reflection in the x-axis. Okay? Because it affects the y-axis, the y values. Just think about it this way. If you've got a minus in front of it, it affects the y values. So it's going to make these positive y values negative. Okay? And the negative values of y is going to make them positive. So it flips. You're still going to need that asymptote at minus 1. Okay? So we'll have the asymptote here. Minus 1. Okay, but as I said, we'll use this as a guide down here now. We're going to reflect this. Okay, so this becomes underneath. Okay, and then you can see then that it'll shoot off to plus infinity with the asymptote there. Okay, make sure you label there the origin where it crosses, and then label your graph minus f of x plus 1. Okay, so you show in the examiner this is the transformation. We've got the asymptote to indicate where it's going, okay, that it is shooting off to infinity as x goes to -1, and then this shows here that it's also going to infinity negative, for negative infinity as x increases.